Now let us talk about their reactivity as reducing agent. We need to know that all of these are good reducing agents. All of these means I'm talking about alkaline earth metals. They are good reducing agents, but remember when their reducing nature or reducing tendency or reducing power is compared with the alkali metals, yes, their reducing tendency is less than the alkali metals because of their smaller size and higher ionization enthalpies. But remember, they are also good or strong reducing agents. They easily loses electrons and forms dye-positive cations, and that is why they are very strong reducing agents, and they are very commonly used for reducing other species. Now, what other important thing you need to know is this, that beryllium, this tendency to act to lose electron, we know that beryllium, magnesium, calcium, strontium, and barium. Now, this tendency to lose electron will definitely increases down the group because size increases and ionization enthalpy decreases. But what we find is that, okay, fine, the tendency of losing electron is least in beryllium, but because of its small size and high hydration enthalpies, what happens is this beryllium it becomes the strongest reducing agent in the group. It's very similar to what we have studied in case of lithium in group 1 alkali metals. In a very similar way, in group 2, beryllium becomes a stronger reducing agent among all the group members because of its small size and high hydration enthalpy. Rest, if we see only their tendency to lose electron, yes, it's the least in beryllium and it increases down the group.